very much, Tracy. Aside from the fact that many of you were here this morning, how many of you feel you have a fairly good understanding of what Sharp 2 is all about? Would you like to explain it for me? As you probably know, Tracy asked me to cover a little bit of the background. It's a federally funded program at about $250 million. We're working on a set of work plans basically that date from about the year 2000, and we're really very pleased that the topics seem to have held up over almost a 15-year period. I'm with Transportation Research Board, and we've done the research work under contract to the Federal Highway Administration in the form of a cooperative agreement. And that part of Sharp 2 is coming to an end in a year, but it will continue in the hands of Federal Highway and AASHTO as they continue to roll out the implementation program. So that's the big picture. The research is done. It's all over, but the shouting at TRB, we're finishing up the last projects, shutting down contracts, closing the program down, and doing outreach, and then supporting Federal Highway and AASHTO in the implementation program. So that's the sort of the status check on the program. This is our mission, is to provide more reliable travel times by reducing non-recurring congestion. And this morning, we talked a little bit about the dichotomy isn't really that clear. If people are in congestion, they don't care what caused it, whether it was recurring or non-recurring. So we have a little work to do to merge the capacity and the reliability sides of this research, but all the pieces are pretty much in place. Ooh, that's the blanks. And these are the four focus areas of the Sharp 2 program. I show this slide because it puts reliability in the middle. Reliability affects everything. If you have too little capacity, you don't have reliability. If you have a poor safety program, you don't have good reliability, and vice versa. If you have poor reliability, you may have poor safety. And the renewal part of the program, which is the rapid reconstruction, a lot of work zones that aren't planned as well as they might be, they generate non-recurring congestion. So all of these things feed in, and from a customer's point of view, they're all part of the same thing. And I think that's eventually where we have to get with the implementation, is these things aren't separate, they're all part of the same thing. Even though this has been dumbed down to 4 buttons, hit the wrong one twice. This is the conventional wisdom on what non-recurring congestion is. You've probably seen this many times, and the last one is inadequate base capacity, so that rolls right back into the larger point of view. But most of the tools that I'm going to be talking about today deal with these issues. This is another way to look at what we've done in the reliability program. We're going to talk today about going from data to analysis to decisions. And it's ultimately all about decisions. It's about getting operations type solutions funded and on the ground. And to do that, you've got to have some numbers. If you remember the 6 points from the capability maturity model this morning, number 3 was performance measures, which means a lot of things, but you've got to have some data to move in that direction. You need some analytical tools. You need some decisions on which performance measures to select, and then you've got to get them in front of the decision makers. And to put it sort of crassly, you've got hard pavement solutions competing with operation solutions, and we're just trying to give the operation solutions a more level playing field. These are the products that are going to be that are available. We'll cover these in a little bit more detail. So the first project is establishing a travel time reliability monitoring system. I'm sure you all collect travel data or buy travel data, do things of that type. But to do this work, you need to know when the incidents were present. You need to know what the weather was like. You need to know if it was just a particularly high demand period. You basically have to analyze the causes of non-recurring congestion. And to do that, you have to operate with about a year's worth of data so you can see the variation. The second project takes some foundational work. It's relatively light on user requirements, and unless you test different solutions. So you might want to try a particular design treatment to improve travel time reliability. This provides you a tool to get an estimate of what might actually happen. And there's quite a number of combinations that you can look at. The LO8 project does a similar sort of thing, but it works in the highway capacity framework. That project, we added 2 chapters to the highway capacity manual that introduced reliability methods, and we upgraded the software, FreeVal and StreetVal, to include the reliability methods so you can test the impact of your design treatments on reliability using highway capacity. This is more complicated. You got to bring more to the table to use these methods, but they do have the advantage of the highway capacity seal of approval. The LO5 project is what I was saying earlier, that you roll all this stuff up and you put it before the decision makers in the choices and trade-offs for what you're going to spend your money on. That's really what it all comes down to. So that LO5 project gives you some guidelines on how you can go about it. You can think your way through that, and we tested these methods with a number of DOTs and MPOs to see how well this was going to sell with decision makers. Finally, the last one, the C11 tool, and excuse me if I do this by the numbers, but it is more efficient. That looks at the impact of reliability on the regional economy. In effect, it gives you a new number for the numerator of your benefit cost analysis. You usually look at direct transportation benefits, safety, travel time savings. But then that also has an impact on the larger economy of the region. This gives you a way to estimate that value. So you're basically bringing more value to the table with your highway project. So we'll talk briefly about the monitoring system. This is the one that lets you analyze what's causing your unreliable congestion or your unreliable travel times, how often it's happening. It has some visualization tools. There's a guidebook for doing this and a report. This is mostly methods. There's no software here, but this is methods. And so your TOC people and your data collection people, this gives you some tools to integrate travel data with the other kinds of data that you need. Now this is the basic visual cumulative distribution function. Basically the travel time index, and there's a number of them, you pick the one you like, versus percent. And the more vertical that curve is, the more reliable or the less variation there is in your travel time. So that's the basic principle. Comes up over and over again in the research, and it's relatively easy to calculate once you put the data collection process in place. But it ain't always that easy. This chart looks at all the host of things that can go wrong. It looks at weather situations, rain situations, snow, work zones in combination with bad weather, and then you have you've parsed out your data to have different curves for different situations. So then you start to get into the analysis of what's actually going on with your roadway system. This is a foundational project. This one doesn't get implemented per se, but it underlies just about everything else. This is the basis for doing the evaluation. And again, you see the cumulative distribution curve. This one, again, travel time index against percentage, and it's sensitive to those items listed on the right. The demand capacity ratio, lane hours, due to incidents, rainfall, and then that project was extended, and now we're looking at snowfall, and we corrected a few inconsistencies that showed up in our pilot tests. So this is the analytical framework. This project worked out the equations and the numerical methods to do the analysis. And since we're engineers here, we like equations, I thought I'd give you a few. These are basically display choices. Some people like the graphs, and basically as you make improvements, that graph will move to the right, becomes more vertical. As you become less reliable, it moves to the left. It moves to the right if it's less reliable. And the equations on the right are basically different choices. There's a 95% versus mean. There's different combinations that you can pick to measure the travel time index, but you're going to have to pick one. It hasn't really sorted out yet. There's a big debate in the literature on which one's better. It's going to be kind of up to you, or maybe it will just sort of shake out, and as usual, we'll all decide to do the same thing. But it's not there yet. They're all valid. They all work, but you got to pick one. And this is a nice feature. Is you have the curve on the right is the baseline condition, and the curve on the left is after you've made some improvements, and the area between is proportional to the change in delay. So that, again, it's this is what the LO7 project I'm going to talk about in a minute. You can feed in some relatively straightforward data, and you can crank these things out and use sketch planning. You see what's sensitive to your situation and what doesn't help. So then this project takes the things I've just talked about, the travel time data and the analytical methods, and makes them operational. So this is an actual tool which is available now. You can get it off the TRB website and soon to be available through AASHTO and Federal Highway Administration. And there'll be a new and improved version coming out before we're done. It's always important to have a new and improved version. But this demonstrates the feasibility and desirability of doing different design treatments. Some of them might not do any good. Some of them might be great. You don't know. So you've got a guidebook that catalogs the kinds of design treatments you might want to take, you might want to look at, a spreadsheet format to enter the data, and it takes relatively simple things you're likely to have: hourly traffic volumes, geometry, incidents. It's not too esoteric on the input side. These are the kind of design treatments you can look at. And these are all things I'm sure you're thinking about every day. You sort of size up a situation and say, well, we might want to do this, we might want to do that. Well, this gives you a sketch planning tool to take it a little bit farther and plug in your data and use some of the default data if that's the best way to go about doing it for you, and you can test these kinds of things. And this is a little easier to see. These are the kind of things you need to run it. Second screen there. And again, if you don't have certain of these things, you can still use it. There's default values. And there's a screenshot. That's the sort of thing that you'd be looking at. You'd be entering your data, getting these kind of outputs, and then you see our cumulative distribution curves. As you try different things, those curves are going to move around, and so you can visually get a sense of what has a big impact, what doesn't. You can look at combinations. We've done some pilot testing, and the pilot test agencies, they like this product. Now, this is the one that involves the highway capacity manual methods. And again, as I said earlier, there's 2 new chapters. And you should know that the National Cooperative Highway Research Program at TRB has a project to take this work and some other work that was done by Federal Highway Administration, and they're coming up with a new version of the Highway Capacity Manual, which will be out in a year and a half. But it will include reliability methods, so they're in the book at this point. Not necessarily easier, but they're in the book. I think I already covered these things. There's a arterial streets version, and there's a freeway version. And this is just a quick sort of summary of the freeway methodology. This has a scenario generator in front of it. There's almost an infinite number of combinations of congestion and work zones and weather, time of day, month, year, lots and lots of combinations. So put a scenario generator to come up with a set of conditions that you then run through the highway capacity manual method with the reliability component, and you get your performance measures out the back end. So this, again, has the advantage that you're in the highway capacity manual tradition. And then this is the urban streets method, which, again, looks at work zones, weather, incidents, effects of operation, signalization, and that sort of thing. And so you can work the arterial street side with the street val piece of software, and you also have the manual methods in the new chapters. So this is the nut of it, getting reliability performance measures into the planning process. And as was mentioned this morning, the planning process is largely a capital improvement program. Quite often operations is not considered in the capital improvement as part of capital improvements. The funding sources may come through other streams, yet it amounts to achieving the same purpose, which is improving customer service on the highways. So this I should mention that this project was conceived long before MAP 21 was written, so this doesn't play directly into the MAP 21 performance measures, and of course we don't even know what they are yet. But this does some thinking on how to bring whatever performance measures you choose, how to bring them into the system, and how to get operations type and improvements at the table when you're considering capacity or capital improvements. So the products here are a report and a guidebook and a technical reference document. You know, there's some of the analytical work from other Sharp 2 projects and other work has been brought into this document. There were some case studies that were done, and the particular interest in there were case studies within the project, and at the end I'll mention some case studies that were done outside of the project. The idea being, how does this play? When you put you put reliability measures in front of your MPO board or in front of the Transportation Commission or whoever's making the decisions in your state, what do they think about it? What kind of questions do they ask? Do they believe it? Because a point I like to make is when you add reliability, you're adding a new value. You've been making road improvements for years, right? And you're taking advantage, reduction in safety and better travel times. Well, this reliability, the public clearly cares about it. It's showing up in what people are willing to pay for tolls, and we have HOT lanes in Washington, and they advertise it as a more reliable way to get around. If you pay the tolls, it's more reliable. But well, again, as you're creating additional value, this is another thing that puts an item in the numerator of your benefit cost equation. So there's value out there that you have not been taking advantage of. So if you're getting positive numbers in your economic analysis, they're going to be even more positive when you throw reliability in. Now that could be controversial. We haven't heard any negative feedback on that, but that's what this amounts to, is we've found a new value in what you guys do for a living, which is improving the performance of highways. And that new value, and there's some other work that's in the literature and also in Sharp 2 on the value of travel time reliability. So we provided tools to measure or estimate the improvement in reliability, and we can put a value on that. Okay, that's good. We're analysts. We think it's good. But do the decision makers buy it? So that's what the pilot tests were all about. And this is sort of how LO5 links in. Clearly, you go from the data to the evaluation strategies to summarizing the program and then prioritizing projects. So this is another way of saying what I started out earlier. There's a flow to these projects. They work in tandem. And then this is a shot from the report on steps to do this. Number one is really important, is getting operations into your policy statement. Get it in at the very high level so people are thinking about it. Selecting performance measures is also pretty important. Like I said earlier, you're going to have to pick. But you got to get this on the table sort of at the philosophical level, and then at the practical level that you're going to pick a measure and pick one that you're going to be able to calculate. And if you don't have, if your organization doesn't have a year's worth of data to do this analysis, you have to go to some other approaches, or you may have to think about putting a data assembly and integration program in place. And of course that's going to cost some money. So these are all decisions that need to get made as you start to move down this path of bringing operations into the capital programming process. And I mentioned earlier the economic benefits are another value that you can add. And here's another screenshot from the report. Basically, you're adding user benefits. You have your direct user benefits. This constitutes an indirect user benefit, which accrues to the land values in the area affected by the improved travel time reliability. And this went back and used some of the data that was collected in the CO3 research that I mentioned earlier. It popped up again in an operational tool here in this program. We did some pilots. We'd done these analytical tools, and of course our contractors told us they worked great. And most of them did, but we thought we'd better go out and kick the tires a little bit. So you can see the 4 sites and different environments that we use, and we worked here with Florida International University to do some of the pilot tests here in Florida. And these are general findings. Each one of those 4 projects has a long report, which they're really quite interesting reading. That overall the feeling was pretty positive about these tools, but they're not perfect. They had some warts. There's some things that needed to be fixed. We did a big fairly good-sized workshop last November in which we brought the pilots in before our governing board, and we went through all this, and then we came up with a list of fixes, and we modified their contracts to make some fixes so these things would work better. And a lot of it was just to make it easier, like you do a scenario, be able to save that scenario, input, output. A lot of the things you just don't do when you're on the first cut in developing a research type product. So we went through one round of improvements, based on the workshop last fall. It was agreed that the LO7 and the C11 projects were the easiest to use. They took the least training and the least background work. LO8 is the most sophisticated of the projects. It has a lot more levers that you can pull. The interface is pretty friendly, but that you really have to get your head into it to use LO8. And then people like the framework from LO5. They found that valuable, and again, the pilot agencies, like everybody else, would like to see a single measure accepted for what reliability is, but it's unfortunately not our job to do that. And so these were some of the fixes that we wanted a little more guidance on the use of the LO2 document for integrating the various kinds of data. Like I mentioned, we fixed some bugs, cut and paste functions, things like that, improved the usability, a little bit more guidance on using the tools. And then there's some future upgrades that we're not going to be able to get around to, but there's some ideas for next steps to make these. And like any product, as these become accepted, they'll change continually, and I think that's a good thing. So we take questions at the end.
No, we have time for a couple questions if anyone has some. No? All right, well, go ahead.
There's one.
On the case studies that you looked at for doing cumulative distribution, and you had the travel time data, how would you put link in weather, incidents, work zones, just throughout the entire year, so you can understand the different impacts that those have on your travel time data?
Well, if the site already had it, they were able to do it from it's basically a historical data situation. You have to be keeping track, and you have to know when these things happen and where they happen, some way to geolocate them. So it's not a trivial matter. Like the LO7 project, it has like weather data from the nearest site for which the National Weather Service provides data. So there's some default sources of weather data, but things like special events and where the work zones were and when they were there, you have to keep track of that yourself. And some of the pilots already had that data. They have a data management system. So it's a pretty big change if you just have travel time data to start getting all these other pieces of data to really have a robust reliability program. LO7 is a sketch planning product that lets you at least skip some of that for now, but then you have to make a decision if you're going to keep track of all these other data items.